Okay, this is a midterm study guide for the midterm for spring 21. I'll be speaking to my class particularly, but I think this will apply to all of our classes. So just make sure that you have any questions that you direct them to your professor. So we'll have a practical and then a number of free response, including a graphing question, and then you'll probably have about 5 multiple choice questions that will largely come from the quizzes, almost completely from the quizzes. So look over those quizzes and make sure that you're familiar with them. So first of all, the practical um, is to be able to build a circuit with 2 resistors in series or parallel, and then with an ammeter or voltmeter measure the current or voltage. So first of all, with the series, that's how we draw the diagram like this. But in practice, it's going to look like this. So you'll have your power supply, positive, negative, that's red and black, and then you'll have your first resistor, and then you'll go to your second resistor. I'm just going to draw the 2 terminals uh, at the end, and then you'll go back to the black. Now, if you want to measure the voltage across any resistor, this is your voltmeter. You take your wires from your voltmeter, and you can just touch them directly to the resistor. So your resistor would be right here. Or you can touch them directly to these leads. Measuring your current is best done in this way. So say you have a resistor on our little wooden boards, and normally the resistor would be right here. If you want to measure the current, the easiest way to do this is to take your resistor and move it so that it's diagonal. Now, it shouldn't go in your circuit like this, only when you're measuring the current. And then put your ammeter in like that, and then that ammeter will now be hooked up in series with that resistor. Notice the current comes in here, it goes through there, it goes through the resistor, through the ammeter, and then back out into your circuit. That's the easiest way to measure the current. It's actually, there are easier ways to do them in series, but this is the surefire, never fail way to measure the current in series with the ammeter. Okay, so with your voltmeter, you can just touch it directly to the leads of the resistor. To measure your current, you take your resistor, move it to a diagonal position, and then hook up your ammeter. After you take out your ammeter, don't forget that you always need to return your resistor back to its regular position so that you don't have a short circuit. So that is the series, and then in the parallel, which our diagram looks like this. With the parallel, it's going to look like this. Here's your power supply. There's your board connected there. You'll have your 2 terminals. That's where your wires connect to. And then you have your resistor right here. And then daisy chain this, because it looks like a little daisy chain, to the next board up. So that's in parallel. Likewise, with the series, if you want to measure the voltage, you just connect the leads of the voltmeter up to the leads of the resistor. And then if you want to measure the current, you do just like you did before, where you take a resistor, you move it in a diagonal position, and then you measure that current. Realize that the resistors will not have a resistance, so you will have no resistance values. They'll be covered up, and you won't be able to see them. And so what you'll need to do on one of these circuits is to measure I for resistor and measure V, and then you calculate the R value. And of course, R is equal to V over I from Ohm's law. All right, so that's the practical part. You will not have to do a combination circuit on this lab, just the series or parallel. The second part is electric fields, be able to draw the electric field and equipotential lines for a configuration of charges. You should go back and look at that. I'll do a couple here. You could have any of them from your lab, but remember we had the dipole where this was positive and this was negative, and what you would have to do is to draw 5 to 6 E field lines. They would look like this, going from positive to negative, and then draw 5 to 6 equal potential lines. And so they go perpendicular to the electric field lines. And so you draw 5 to 6 of these, sort of like that. That's one of them. Another one that we did looked like this, where you just had 2 parallel plates. and the electric field lines look pretty straight in the middle, and then as you got out to the edges, they sort of curved around like that, and then my equal potential lines, sorry, that's not really right. They curve a little bit here, and then they straighten out, and then they curve in the end. Should look something like that. You need to know how to do the others. I'm not going to draw them here, but you should, I mean, I'll draw them. You had one like this. You had one like this. I think that was all that you had. Okay, so look back in your lab manual and remember how you did those equipotential lines. If you're uncertain, you can always go to PhET e-fields and you can play around with these there. Just Google PhET e-fields, and that was one of the labs that we did. Okay, so the next part, capacitors and electric permittivity. What you have to do here is to be able to manipulate this equation, kappa epsilon naught A over D, and remembering that these values refer to, this is the cross-sectional area of those plates, that's A. D is the distance between the plates. Kappa, if you have a dielectric between them, that's the dielectric constant. They'll be fairly simple equations where you're just applying those to figure out what is the area or displacement around, area or separation between those values. Oh, also be able to solve for the equivalent capacitance. So if I have two capacitors in series, I'll call this C1, C2. That is going to be the equivalent is 1 over C1 plus 1 over C2. That's the equivalent capacitance. If I have capacitors in parallel, the equivalent is the sum. C equivalent is equal to C1 plus C2. Okay, the next one is given data for V, I, or R, be able to use Ohm's law to calculate the other, and then also given data for V, I, or R, be able to graph the data and determine the unknown variable. So I think the first of those is fairly straightforward. That is, if I have V, I, or R, that I be able to solve for the unknown quantity. Okay. The next, though, is more complicated. Let's say in lab, I think, well, we did several combinations, but I'll do this one. So if I have data for V and I, how do I solve for R? How do I find R? And what we'll be looking for here is that we will plot on the y-axis. Let's see, actually, I'm going to redraw this or rewrite this equation as I is equal to hold on, I'm sorry. Okay, I'm sorry, no, never mind this. So if I want to do this, I plot V versus I. That should be a straight line. Now you'll have data points around, and then I find 2 points on that line to find the slope of that line. Once I find that slope should be equal to R because V is on the y-axis, I is on the x-axis, and so the slope is going to be R. That is V, I, so I'll have R will be the slope. The y-axis is V, the x-axis is I, so that means that the slope is R. Now, another way that I might do this is that instead of giving you, as we did in lab, instead of giving you that, I would give you, say, I and R and ask you for V. So if I give you data for I and R, what are you going to do? Well, I'm going to plot my dependent variable, I, on the y-axis, and I'm going to plot 1 over R on the x-axis. Now you might ask, how did I get that? Well, I have I is equal to 1 over R times V. That is the Ohm's law written in that way. In fact, I'm going to write this in a slightly different way as V times 1 over R. So I have this on my y-axis, I have this on my x-axis, and now this will be my slope. So I plot that data, and then I find a best fit line, and then I find the 2 points on that line, and I calculate the slope, and I find that slope. And that slope will be equivalent to V. Now, of course, in the process of this, I'll have to calculate 1 over R. Look back on your lab manual. We talk about this in the lab manual, how to do this. And you've done this a lot in previous semesters, and you've done it a couple times this semester. But this is an important part of this lab. You shouldn't walk away from this course without knowing how to do this kind of data analysis. Looking at a function that describes some physical phenomena and applying that to data so that you can use data to figure out some unknown quantity. In this case, either the current or the resist or the voltage. All right. And then also in lab 4, you need to be able to calculate the resistivity. That's usually, we've done this in class, where R is equal to rho L over A. Given these quantities, R, L, and A, be able to solve for the resistivity, or like we've done in class, where you calculate the resistivity and you find the unknown material based on those resistivities. That's Ohm's law. Ammeters and voltmeters, be able to describe the purpose, use, and construction of a voltmeter, ammeter, and galvanometer. So ammeters, several things to know. They consist of a galvanometer plus a small resistor. They measure current. They are connected in series. And to multiply their range, you add a shunt resistance in parallel. Remember, we added that shunt resistor just directly to the terminals of that ammeter. For voltmeters, this is a galvanometer plus a big resistor. The voltmeters have a very big resistance. Remember, I think it was 10,000 ohms what you measured it to be. These measure V. You hook them up in parallel. And in order to multiply their range, you add a multiplier resistance. I'll call this R mult. And you add that in series. Now in lab, we did several times where we were trying to figure out what is the resistance or the resistance of either the ammeter or the voltmeter. And what we did was quite simple, is that we determined the current going through an ammeter. We found out what it was, say 1 amp, for example, and then we measured the voltage, whatever it was, let's say it's 0.05 volts, and then we used that to figure out what was the resistance. And we just used Ohm's law. So if V equals IR, R is equal to what? V over I. That was 0.05 divided by 1, so 0.05 ohms. It was actually less than that, I think. Okay, so be able to do that. Let's see. After that, we have to do resistors in series and parallel. And so you need to be able to find the equivalent resistance and the voltage and current for each resistor in a series or parallel circuit. So no combination, we're just doing series and parallel. So I'll do a couple of examples. Let's say that we have a 12-volt battery, 12 volt with say a 2 ohm and 4 ohm resistor. The equivalent of that would be 6 ohms. With 12 volts, that means that my current coming through here is V over R, or 2 amps. It means I have 2 amps here and 2 amps here. So once I do that, I can find out 2 times 2 is 4 volts and 2 times 4 is 8 volts. For our example, that's a good simple one. Now let's do parallel. Say if I have 12 volts here, and let's say 3 ohms and 4 ohms. Actually, let's not do that. Let's do 3 and 6 ohms. The equivalent resistance of this is going to be 1 over a third plus a 6. That's equal to, what is that, 2, 6 plus 3, 6? What is it? It's 3, 6. That's equal to 2 ohms. So my equivalent resistance will be 2 ohms. I have 12 volts. By the way, that means that I have 6 amps, 12 over 2, so I have 6 amps coming up here. I also know that resistors in series and parallel have the same voltage, so each of these has 12 volts and 12 volts. I can calculate the current here is going to be 12 divided by 6 or 2 amps, and 12 divided by 3 or 4 amps. So that's the currents going there. And notice that this current, 6 amps, is equal to 4 plus 2, as it should be by the junction rule. Those are the two circuits. You'll need to be able to calculate the total current for the parallel and the current and voltage in any one of the resistors. I think that's it.